February 22nd, 1943. Sbeitla, Tunisia. German tank crews from Panzerabteilung 501 surrounded an abandoned American Sherman, its engine still warm. The tank bore a name painted on its hull, War Daddy II. Inside, German engineers discovered something that would perplex their technical experts for the remainder of the war. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. A gyrostabilizer system that kept the 75mm gun locked on target while the tank bounced across rough terrain. The device represented American industrial capacity in miniature. Westinghouse had manufactured thousands of these stabilization units, installing them in nearly every Sherman variant except those armed with 105mm howitzers. Yet, as German technicians would discover over the following months at Kummersdorf testing facility, understanding the system and replicating it were entirely different challenges. This is the documented story of how Germany's most accomplished tank engineers confronted American technology that remained beyond their grasp, not because they lacked the theoretical knowledge, but because the industrial infrastructure required to produce such systems at scale had already collapsed under the weight of total war. The journey of War Daddy II began at the Battle of Sidi Bou Zid, where inexperienced American tank crews from the 1st Armored Division faced combat-hardened German forces. In the confusion of battle, tanks were abandoned on the battlefield, some damaged beyond immediate repair, others left behind as crews retreated under heavy fire. War Daddy II fell into German hands, intact enough to drive. The German tank crews, recognizing the intelligence value of capturing an enemy tank undamaged, drove the Sherman 350 kilometers to Tunis, over 4.5 days. The tank, still bearing its American markings, was loaded onto a ship bound for Germany and the Army Weapons Office testing facility. At Kummersdorf, located 25 kilometers south of Berlin, the Wehrmacht maintained its primary weapons testing and evaluation center. Since 1875, this facility had served as the proving ground for German military technology. By 1940, following the General Staff's explicit orders, each new captured enemy armored vehicle was to be provided to Kummersdorf in duplicate for extensive testing. War Daddy II arrived bearing serial number WH058941. German engineers immediately began systematic documentation, photographing the tank from every angle, measuring armor thickness in millimeters, recording armor slope in degrees. The Sherman sat alongside captured British Matildas, French Char B1s, and Soviet 34s, forming a collection that represented every major opponent Germany faced. But the Sherman presented unique puzzles. Unlike captured Soviet tanks, which German engineers often criticized for crude construction despite effective design, the Sherman exhibited American manufacturing philosophy in every component. Everything was standardized, interchangeable, designed for rapid replacement rather than complex repair. The gyrostabilizer, however, demanded particular attention. The system consisted of a gyroscope spinning at 12,000 revolutions per minute, powered by 26-volt, 400 Hz, three-phase electrical current. Hydraulic power drawn from the turret drive system controlled the gun in the vertical plane while the tank moved. The mechanism could maintain the gun's elevation setting within 1/8 of a degree 2 mils in military terminology, while crossing moderately rough terrain at 15 miles per hour. German engineers documented every component. The system used a Westinghouse electric motor connected through reduction gears to the stabilization mechanism. The gyroscope itself represented precision manufacturing that Germany's increasingly strained industrial base struggled to match by 1943. Albert Speer, Minister of Armaments and War Production for the Reich, personally visited Kummersdorf to examine captured American tanks. Photographs from this period show Speer sitting in the commander's hatch of a Sherman, seeing firsthand what American industry had achieved. The images capture a moment of realization that America's industrial capacity had produced not just more tanks, but tanks containing technological sophistication Germany could observe but not replicate. The stabilizer's effectiveness was debatable even among American crews. Some Sherman crews swore by the system, using it to engage targets more quickly after short halts. Others found it complicated to set up properly and disconnected it entirely. Many American armor units received their tanks with minimal training in the stabilizer's operation, never learning to exploit its full capabilities. But capability and implementation were separate questions. The fact remained that Westinghouse had manufactured these units by the thousands, installing them across Sherman production, while German industry struggled to maintain even basic electric turret traverse on late-war Panzer IV tanks. The German Army Weapons Office conducted firing trials, comparing the Sherman against German tanks. Test reports documented that the Sherman's gyrostabilization provided measurable advantages for quick firing after short halts, valuable in mobile engagements where tanks stopped briefly to engage targets before continuing the movement. Yet Germany never attempted to install similar systems in wartime tank production. The reasons went beyond simple technical challenge. Germany's tank development philosophy had evolved differently from American approaches. German engineers focused on firepower and armor protection, accepting mechanical complexity and reduced reliability as necessary costs. The Panther tank, weighing 43 metric tons and costing 120,000 Reichsmarks without radio or gun, represented this philosophy. The Sherman, by contrast, weighed 33 tons and prioritized reliability above all. Its automotive components, the transmission, final drives, suspension, were designed for extended operation, without breakdown. German tank mechanics, struggling to keep Panthers operational, recognized immediately that the Sherman represented mechanical engineering philosophy they could only admire. Even the apparently simpler aspects of Sherman design revealed American industrial advantages. The cast turret, formed as a single piece, streamlined production while providing good protection. The 69-inch turret ring, larger than any German tank except the Tiger, allowed for future upgrades that kept Shermans combat effective for decades after the war. The Germans captured Shermans not just in Tunisia, but throughout the war. British Shermans fell into German hands in Italy and France. Soviet-operated Shermans were captured on the Eastern Front. The 10th SS Panzer Division operated a separate unit of 10 Shermans at one point. German forces used captured Shermans extensively, often preferring them to German tanks for certain roles. Captured Shermans served as armoured recovery vehicles, their reliable powertrains and robust motors proving ideal for towing disabled tanks. German tank mechanics found even the Sherman's most complex engine variant, the Chrysler, a 57 multibank, easier to troubleshoot and maintain than German designs. The contrast between recovering a broken Panther with a reliable Sherman versus attempting to use a Berger Panther recovery vehicle that itself broke down was not lost on German crews. During the Battle of the Bulge, German armour sometimes operated captured Shermans alongside German tanks. The Shermans, marked with German crosses, led columns where their silhouettes might confuse. American tank crews momentarily a tactical advantage born of desperation rather than preference. At Kummersdorf, the collection of captured American tanks grew. After war Daddy II came more Shermans M4A2s, M4A3s, British Sherman Fireflies mounting 17-pounder guns. Each was photographed, tested, analysed. German intelligence reports detailed their strengths and weaknesses with clinical precision. The reports acknowledged what German tankers in the field already knew. The Sherman's gun, while adequate against Panzer IIIs and early Panzer IVs, struggled against the armour of Panthers and Tigers. The 75mm frontal armour couldn't stop German anti-tank guns. The tank's height, nearly 3 meters above ground, made it an easy target. But the reports also documented characteristics that troubled German observers. The Sherman's mechanical reliability exceeded German tanks by significant margins. Its ease of maintenance meant damaged tanks returned to action quickly. Most significantly, American industry produced 50,000 Shermans, while Germany struggled to build 6,000 Panthers. The gyrostabilizer represented this disparity in microcosm. It wasn't that German engineers couldn't understand the technology. The principles of gyroscopic stabilization were well established. What German industry lacked by mid-war was the capacity to manufacture such systems at scale, while also producing tanks, ammunition, aircraft, and countless other weapons systems. Consider the production requirements. Each stabilizer needed precision machining, specialized electrical components, hydraulic systems, integrated with turret drives. The gyroscope itself, spinning at 12,000 RPM, required manufacturing tolerances that Germany's bomb-damaged factories increasingly struggled to maintain. Germany's industrial situation deteriorated throughout 1943 and 44. Allied bombing disrupted their production, destroyed specialized machine tools, killed skilled workers. The shortage of strategic minerals, particularly tungsten and molybdenum, forced compromises throughout German weapons production. Tungsten scarcity forced jet engine redesigns using simple steel, resulting in engines that burned out after just hours of operation. In this context, adding gyrostabilizers to tank production was impossible. Germany couldn't even maintain electric turret traverse on all tank variants. Late-war Panzer IV series tanks had electric turret traverse deleted entirely, forcing crews to traverse turrets manually with hand wheels, a reversion to 1930s technology born of necessity. The American M4 Stuart light tank featured the Westinghouse vertical gyrostabilizer from mid-1941, before America even entered the war. This decision demonstrated American industrial confidence, the ability to add technological sophistication to mass-produced weapons without compromising production rates. German tank development followed different imperatives. When the Wehrmacht encountered Soviet 34s in 1941, German High Command demanded immediate response. The result was the Panther, designed and rushed into production with inadequate testing. Early Panthers suffered catastrophic reliability problems. Transmission failures, engine fires, final drive breakage plagued Panther units. The contrast was stark. America produced a reliable medium tank incorporating advanced features like gyrostabilization, then built it by the tens of thousands. Germany designed a technically superior tank on paper, better gun, better armor, better mobility, but couldn't produce it reliably or in sufficient numbers. German engineers at Kummersdorf understood these realities. Their reports documented not just what American tanks could do, but what American industry had achieved. The Sherman's gyrostabilizer wasn't just a clever device. It was evidence of an industrial system that could incorporate sophisticated technology into mass production without sacrificing reliability or quantity. The testing continued through 1944. More captured Shermans arrived, including late production models with improved armor and 76mm guns. Each variant was evaluated, its capabilities catalogued. The Germans noticed improvements: better vision cupolas, upgraded suspensions, more powerful guns. But one feature never appeared in German tank production: gun stabilization comparable to the Sherman's system. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. By late 1944, Kummersdorf's role was changing. The Soviet advance toward Berlin made the facility's location increasingly precarious. The collection of captured tanks, including multiple Shermans, represented intelligence value and potential combat assets. On March 9, 1945, the commander of Army Group Vistula signed orders transferring museum tanks to units defending Stettin. Some tanks saw combat in Berlin's final defense. A 35 heavy tank joined Combat Group Ritter fighting near Zossen. Captured British cruiser tanks, knocked out alongside a destroyed Panther, were photographed on Berlin's outskirts. Shermans from Kummersdorf joined makeshift units formed in desperation as Soviet forces closed in. The irony was complete. German engineers had spent 2 years examining captured American tanks, documenting their features, understanding their capabilities. Yet Germany's wartime production never incorporated the lessons that might have mattered, not the specific technologies like gyrostabilizers, but the industrial philosophy that made such features possible. The fundamental problem wasn't German engineering capability. German engineers understood gyroscopic principles, hydraulic systems, precision manufacturing. What they lacked was the industrial ecosystem that made American mass production of sophisticated components possible. Consider the supply chain requirements for a single gyrostabilizer. The Westinghouse unit required specialized electric motors, precision-machined gyroscopes, hydraulic pumps, control systems, wiring harnesses designed for tank environments. Each component depended on sub-suppliers, providing raw materials, machined parts, electrical components. The entire system required quality control, maintaining tight tolerances across thousands of units. American industry possessed this infrastructure. Westinghouse operated factories with trained workers, specialized machine tools, established supply chains. When the Army Ordnance Department specified gyrostabilizers for Sherman production, Westinghouse scaled up manufacturing without disrupting tank assembly lines. The stabilizers arrived at tank factories Lima Locomotive Works, Prest, Steel Car Company, Pacific Car and Foundry, Fisher Body, Federal Machine and Welder, American Locomotive Company, Baldwin Locomotive Works, Pullman Standard, Detroit Arsenal ready for installation. Germany's industrial structure couldn't replicate this. Tank production was distributed among manufacturers who competed for resources, workers, materials. The Panther alone required production expansion from MAN to include Daimler-Benz, Maschinenfabrik Niedersachsen-Hannover, and Henschel and Sohn. Initial production targets of 250 Panthers monthly at MAN increased to 600 by January 1943. But this figure was never reached due to Allied bombing, manufacturing bottlenecks, and component shortages. Adding gyrostabilizers to this struggling system was inconceivable. Germany couldn't maintain production of simpler components. The shortage of specialized machine tools needed for machining Panther hulls delayed initial production. When Panthers finally reached units in December 1942, they suffered reliability problems from rushed production. The German response to captured American technology revealed institutional limitations beyond manufacturing. Soviet 34 captures in 1941 prompted immediate German analysis and response. Within months, German engineers had dissected 34 design, understanding its sloped armor, wide tracks, diesel engine, and effective 76mm gun. This analysis directly influenced Panther development, but analysis and implementation diverged. The Panther incorporated some 34 features sloped armor, large gun while rejecting others. German engineers couldn't or wouldn't adopt the 34's simple, robust construction. The Panther emerged as a sophisticated tank requiring skilled maintenance, complex repair, and constant mechanical attention. Sherman analysis followed similar patterns. German reports documented Sherman strengths: mechanical reliability, ease of maintenance, automotive excellence, production efficiency. Yet German tank development continued prioritizing firepower and armor over reliability and producibility. The institutional momentum of German tank design philosophy couldn't shift, even when confronting evidence that different approaches might be superior. The gyrostabilizer represented technology beyond German replication, not because of complexity, but because of context. Installing stabilizers required stable production, reliable supply chains, quality manufacturing, trained workers, and industrial capacity beyond immediate military necessity. Germany lacked all of these by 1943. German tankers who operated captured Shermans provided field reports that contradicted official narratives. Crews praised Sherman reliability, ease of operation, automotive performance. German mechanics expressed admiration for Sherman engineering transmissions that didn't fail, catastrophically, engines that started reliably, suspensions that didn't break under normal operation. These reports existed alongside other German assessments criticizing Sherman armor, firepower, height. The simultaneous existence of praise and criticism revealed the complexity German observers faced. The Sherman was inferior in direct tank combat against German heavy tanks, yet superior in virtually every other measure of tank design excellence. The captured Sherman inventory at Kummersdorf represented this complexity. Each tank was simultaneously an intelligence asset, a technological curiosity, and eventually a combat necessity. As Germany's situation deteriorated, the distinction between captured tank as study object and captured tank as combat vehicle blurred entirely. By late 1944, some German units operating captured Shermans had integrated them permanently into their formations. The Ist-Kriegsgliederung of May 8, 1945, shows that 3rd Panzer Company of Panzerabteilung 346 had 5 Panzer IIIs and 3 Sherman tanks, 1 76mm Sherman and 2 75mm Shermans. These weren't temporary expedients but official unit compositions. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The Germans marked captured Shermans with Balkenkreuz, the Iron Cross insignia, and German tactical numbers. Crews operated them alongside German tanks, often placing Shermans at column heads where their silhouettes might provide momentary tactical advantage. During the Battle of the Bulge, German forces used captured American uniforms, vehicles, and equipment in Operation Greif, attempting to create confusion behind American lines. But operational use of captured tanks, however extensive, was admission of failure. Nations with robust tank production don't rely on enemy vehicles for frontline combat. Germany's use of captured Shermans, 34s, and other Allied tanks revealed industrial desperation masked as tactical flexibility. The technical reports from Kummersdorf documented this desperation implicitly. Each captured tank analysis noted features German production couldn't match. Sherman automatic transmissions simplified crew training. American radios worked reliably. Vision devices provided better crew awareness. Small features like the Sherman's escape hatch in the hull floor, which Marines in the Pacific used in reverse to recover wounded under fire, demonstrated design sophistication throughout the vehicle. The gyrostabilizer remained the most visible symbol of American industrial advantage, but it wasn't alone. Every Sherman component told similar stories. The cast turret, formed as a single piece by American foundries, required manufacturing capabilities Germany struggled to maintain under bombing. The rubber-bushed track blocks, providing smoother ride and better durability, depended on rubber supplies Germany lacked. Even the simple things, the quality of welds, the consistency of armor plate, the reliability of electrical systems separated American and German production. German engineers recognized these differences. Their reports, preserved in archives, don't make excuses. They document facts clinically. American tanks exhibited superior mechanical reliability, better manufacturing quality, more consistent performance. The reports note that captured Shermans often ran better than German tanks fresh from factories. This recognition didn't translate into action because action was impossible. Germany's industrial base, already stretched beyond sustainability by 1943, was collapsing under combined pressures of Allied bombing, resource shortages, and overwhelming production demands. Adding new manufacturing requirements like gyrostabilizers to this system would have reduced overall output without providing commensurate combat advantage. The cost-benefit analysis was stark. A gyrostabilizer might improve first-shot hit probability while moving, but German doctrine emphasized firing from stationary positions anyway. The tactical advantage didn't justify the industrial investment, especially when that investment might reduce production of guns, ammunition, or complete tanks. This reasoning contained its own trap. By refusing to invest in features that didn't provide immediate combat advantage, German production optimized for current conditions, while American production prepared for future requirements. The Sherman's large turret ring, initially unnecessary for the 75mm gun, later accommodated 76mm and even 17-pounder guns. American design philosophy built in growth potential. German tanks, optimized for immediate requirements, struggled to accommodate upgrades. The Panther's 65-inch turret ring limited gun options. The Tiger's electrical system, already stressed by the tank's demands, couldn't support additional systems. German tanks reached their design limits quickly. while Sherman variants continued developing throughout the war and decades beyond. The contrast extended beyond individual vehicles to entire production systems. American tank production was distributed across manufacturers who nonetheless built to common standards. A Continental radial engine from one factory fit any Sherman variant using that power plant. Track blocks were interchangeable across thousands of tanks. Transmission parts could be swapped between vehicles. German production lacked this interchangeability. Panther components from different manufacturers sometimes didn't fit together. Tiger transmissions required special tools and skilled mechanics. The diversity of German tank models, Panzer III, Panzer IV, Panther, Tiger, Tiger II, numerous assault guns and tank destroyers multiplied logistics complexity exponentially. When German crews captured Shermans, they discovered tanks simpler to maintain than German designs. Oil changes used standard procedures. Track maintenance required common tools. Engine access was straightforward. The Sherman wasn't simpler because American engineers lacked sophistication. It was simpler because American engineers prioritized maintenance ease as a design requirement. This philosophy extended to the gyrostabilizer. The Westinghouse unit was designed for field replacement. If the stabilizer failed, crews could disconnect it and fight without it. The system didn't compromise basic tank functionality. German engineers, examining this design, noted the foresight building systems that degraded gracefully rather than failing catastrophically. The captured Shermans at Kummersdorf, photographed extensively by German technical staff, show details, revealing American manufacturing quality. Welds are consistent, casting quality is high, components fit precisely. These aren't accidents but evidence of manufacturing systems maintaining quality control across massive production runs. Germany's manufacturing quality declined throughout the war. Early war German tanks showed excellent craftsmanship. Late war production exhibited increasing variation, rougher welds, less precise fits, substituted materials. The same bombing and resource shortages that prevented gyrostabilizer production degraded quality across all production. American production, protected by geography from bombing, maintained consistency. A Sherman, built at Fisher Body in 1945, exhibited the same quality as one built at Lima Locomotive in 1942. This consistency, invisible in combat but crucial for logistics, represented industrial advantage as significant as any specific technology. The gyrostabilizer story, therefore, isn't really about gyrostabilizers. It's about industrial systems, manufacturing philosophy, and national capacity. Germany could have built gyrostabilizers in small numbers for testing. German engineers understood the technology completely. What Germany couldn't do was build them by the thousands while also building tanks, guns, aircraft, ammunition, and everything else total war demanded. American industry accomplished this because it had been built, from the beginning, for mass production of complex goods. The automotive industry infrastructure that produced millions of cars before the war converted to producing hundreds of thousands of tanks, aircraft, and vehicles during it. The same supply chains, manufacturing expertise, and quality systems that made automobiles made weapons. Germany's industrial base, smaller and less developed, struggled with comparable challenges. German automotive production before the war was a fraction of American output. The expertise in mass production, quality control, and supply chain management that American industry possessed simply didn't exist at the same scale in Germany. When War Daddy II arrived at Kummersdorf in 1943, German engineers saw evidence of this, a disparity in every component. The gyrostabilizer was merely the most obvious symbol. Every system, every part, every design choice reflected industrial capabilities Germany couldn't match. The story's conclusion writes itself in the historical record. Germany never installed gun stabilization systems in wartime tank production. The technology remained beyond German industrial capacity until war's end. Post-war, both British and Soviet tank designers developed improved gun stabilizers. The British Centurion Mark III in 1948, the Soviet T-54A with STP-1 stabilizer in 1954. But during World War II, only American tanks featured gyrostabilization as standard equipment. Only American industry possessed the capacity to mass-produce sophisticated components without compromising quantity or reliability. The Sherman's gyrostabilizer, examined closely by German engineers but never replicated in German tanks, stands as testament to American industrial supremacy in the Second World War. The gyrostabilizer's absence from German tank production represented more than a single technological gap. It symbolized the fundamental divergence between American and German approaches to modern warfare, a divergence that extended from factory floors to battlefields across 3 continents. In the field, German tankers who encountered Shermans developed complex, sometimes contradictory assessments. Otto Carius, the Tiger Ace, acknowledged in post-war interviews that the Tiger was mechanically unreliable compared to Allied tanks. German crews operating captured Shermans reported experiences that contradicted official narratives about American tank inferiority. These crews discovered that Shermans started reliably in cold weather, maintained speed over long distances, and required minimal maintenance between engagements. The 3rd Company of Heavy Tank Battalion 503, operating in Normandy, captured several Shermans and Sherman Fireflies. German reports from this unit noted that captured Shermans proved more reliable than their own Panthers and Tigers for sustained operations. Crews could operate Shermans for days without mechanical failure, a level of reliability German tanks rarely achieved. At Villers-Bocage in mid-June 1944, German forces captured a Firefly from the 4th County of London Yeomanry. This Sherman variant mounted the British 17-pounder gun, giving it firepower comparable to German heavy tanks. German technical examination revealed that British engineers had successfully integrated a powerful gun into the Sherman's chassis while maintaining the tank's fundamental reliability. The gyrostabilizer, adapted for the larger gun, continued functioning normally. This observation troubled German analysts. The Sherman's design allowed for substantial upgrades without compromising basic systems. The large turret ring that seemed unnecessarily spacious for the 75mm gun now accommodated much more powerful weapons. This design foresight building in upgrade capacity from the beginning represented planning that German tank development lacked. German tank design evolved reactively. The Panzer IV, initially a support tank with a short 75mm gun, received progressively longer guns as combat requirements changed. Each upgrade stressed the chassis, suspension, and drivetrain beyond original specifications. By late war, Panzer IV variants were mechanically overburdened, their reliability declining as firepower increased. The Sherman, conversely, handled upgrades gracefully. The chassis, designed in 1941, still accommodated improvements in 1945. This wasn't luck, but deliberate engineering philosophy building systems with margin for growth. American engineers anticipated that combat would reveal requirements beyond initial specifications, so they designed flexibility into the platform. The gyrostabilizer embodied this philosophy. Early Sherman models featured the stabilizer despite uncertain tactical value because American doctrine assumed mobile warfare requiring fire on the move. Whether crews used the feature effectively was secondary to having the capability available. This abundance mentality, including features that might prove useful, contrasted sharply with German scarcity thinking. By late 1944, German tank production faced cascading failures. The Panther's initial production target of 600 monthly was never achieved. Tiger II production peaked at 84 tanks in August 1944 before declining. Even the simpler Panzer IV saw production drop as factories were bombed, workers conscripted, and materials diverted to other weapons. Meanwhile, American Sherman production exceeded 49,000 tanks by war's end. Soviet 34 production surpassed 84,000. The numerical disparity was crushing. Germany's qualitative advantages in individual tank combat couldn't overcome quantitative disadvantages of 10-1 or worse. German tanker accounts from the Battle of the Bulge illustrate this reality. During Operation Autumn Mist, German armoured forces achieved initial surprise and significant advances, yet within days, the offensive stalled as German tanks ran out of fuel, broke down, or were overwhelmed by superior numbers of Allied tanks and tank destroyers. The plan had depended on capturing American fuel supplies, an assumption that revealed Germany's desperate logistics situation. Some German units in the Bulge operated captured Shermans marked with German crosses. On January 17, 1945, at Herlisheim, SS Hauptsturmführer Erwin Bachmann's 1st Company of SS Panzer Regiment 10 captured 12 M4A375W Shermans from the 43rd Tank Battalion. These tanks were quickly repainted and integrated into German operations. The irony was unavoidable. Germany's elite units relied on enemy equipment to maintain combat effectiveness. The captured Shermans performed reliably for their new operators. German reports noted that American tanks required less maintenance, consumed less fuel per kilometre, and suffered fewer mechanical breakdowns than comparable German vehicles. These weren't subjective opinions, but documented operational realities that validated everything German engineers at Kummersdorf had observed. The gyrostabilizer, when German crews actually learned to use it, provided tactical advantages German tankers appreciated. The ability to keep guns on target while moving, even if not firing accurately, allowed faster target acquisition when stopping. Experienced German crews using captured Shermans exploited this feature, compensating somewhat for the Sherman's firepower disadvantage against German heavy tanks, but individual tank capabilities mattered less, as Germany's strategic position collapsed. By early 1945, the Kummersdorf facility itself became a combat zone. The massive Soviet offensive toward Berlin overran testing grounds, factories, and military installations across eastern Germany. The captured tanks at Kummersdorf Shermans, 34s, British cruisers, French heavy tanks were pressed into final defensive battles. The Panzer Company Kummersdorf, formed on March 31, 1945, included 1 Jagdtiger, 2 Panzer IVs, 1 Panzer III, 1 Nashorn, 1 Hummel, 2 Shermans, and an immobile Porsche Tiger I. This makeshift unit, cobbled together from museum pieces and test vehicles, represented the desperation of Germany's final weeks. Tanks that had been carefully studied as intelligence assets now fought as last resort combat vehicles. Even the massive Maus super-heavy tanks, weighing 188 tons and representing the pinnacle of German over-engineering, were at Kummersdorf during the final battles. Both prototypes were destroyed as Soviet forces approached, though one hybrid vehicle turret from the second Maus mated to the hull from the first survived, and now resides at the Kubinka Tank Museum in Russia. The contrast between the Maus and the Sherman encapsulated the divergent paths of German and American tank development. The Maus represented extreme specialization, a tank so heavy and complex it could barely move, requiring special transportation, enormous fuel consumption, and constant maintenance. Only 2 were ever built. The Sherman represented balanced design, adequate firepower, sufficient armour, excellent mobility and reliability, built by the tens of thousands. German engineers examining the Sherman's gyrostabilizer in 1943 couldn't have predicted this outcome, yet the seeds were visible. The stabilizer wasn't revolutionary technology. It was evidence of industrial maturity, the capacity to incorporate sophisticated features into mass production without sacrifice. This capacity, not any single technology, determined the war's material outcome. Post-war analysis confirmed these conclusions. American and British technical missions examining German weapons and facilities found sophisticated prototypes and experimental systems. Germany had developed jet aircraft, ballistic missiles, advanced submarines, and numerous other advanced weapons. But the gap between prototype and production, between laboratory and battlefield, had proven unbridgeable. The Sherman, with its gyrostabilizer and countless other features, demonstrated that production capability mattered more than prototype sophistication. A reliable tank produced by the thousands outweighed a superior tank produced by the hundreds. American industry understood this principle from the beginning. German industry learned it too late. The legacy of the Sherman's Gyrostabilizer extends beyond World War II. Post-war, tank development by all nations incorporated gun stabilization as standard equipment. The British Centurion, the Soviet T-54, and American post-war tanks all featured increasingly sophisticated stabilization systems. The technology that Germany examined but never replicated became universal within a decade of war's end. Modern main battle tanks, the Monet Abrams, Leopard 2, Challenger 2, feature stabilization systems descended directly from the Sherman's Westinghouse unit. Today's systems use digital gyroscopes, computer fire control, and laser rangefinders. But the fundamental principle remains unchanged. The gun must remain on target, regardless of vehicle movement. The story of German engineers examining the Sherman's Gyrostabilizer, understanding its function, yet never installing similar systems in wartime German tanks, reveals truths about total war, industrial capacity, and technological competition. Germany possessed talented engineers, sophisticated understanding of advanced technologies, and the world's most experienced tank crews by mid-war. What Germany lacked was the industrial ecosystem supporting mass production of complex systems while maintaining quality and quantity. The Kummersdorf testing facility, where War Daddy II underwent exhaustive German examination, no longer exists as it did during the war. The site, now in Brandenburg, hosts memorials and historical markers. The captured tanks that survived the war's end were destroyed, captured by Soviets, or scrapped. War Daddy II's final fate is unknown, whether it fought in Berlin's defense, was destroyed during retreat, or simply disappeared in the chaos of Germany's collapse. What remains is the documented record. German technical reports on captured Shermans, preserved in archives, detail every aspect of American tank design. The gyrostabilizer receives particular attention: diagrams, measurements, analysis of function. These reports represent German engineering expertise confronting American industrial capability, understanding what they saw, recognizing they couldn't replicate it. The Sherman wasn't the war's best tank in direct combat. German Panthers and Tigers could destroy Shermans at ranges where Shermans couldn't effectively return fire. Soviet 34s offered comparable capabilities at lower cost. British development of the 17-pounder Firefly proved that the Sherman chassis could be significantly improved, but the Sherman was the right tank for America's war. It was reliable enough to cross oceans and continents, simple enough for conscript crews to operate effectively, versatile enough to fulfill multiple roles, and producible in quantities that ensured overwhelming numerical superiority. The gyrostabilizer, examined closely by German engineers but absent from German tank production, symbolized these qualities: sophisticated technology made routine through industrial excellence. In the end, the story of the gyrostabilizer is the story of the war itself, not decided by individual weapon superiority or tactical brilliance, but by industrial capacity, logistics mastery, and the ability to produce sophisticated equipment reliably and abundantly. Germany's finest engineers understood the Sherman's gyrostabilizer completely. They simply couldn't build it while also fighting a war on 3 fronts against enemies who could. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.